is variably subnetted. How many subnets? 2. Yes. So it tells you that means we have 2 is subnetted 2 times. It has 2 subnets that falls under this network address. This is the network address, like I said. These are the connected. Locally, these are the IP addresses, 1.1 and 2.1. So it tells you, C, it represents that it tells you that it is directly connected. Here, the code is the logic. L for local, C for connected, S static, R for RIP, M mobile, and stuff like that. C, or here, C connected. That means they are directly connected to that router. Hold on again. So that means these are the things that you're supposed to be, that you're supposed to know. Should I ask you theory when you are writing, right? Then I ask you, Oguchi, what does the code L represent? You must know local. What does the code P represent? You must know. Does it make sense? Yes. So now, hence I was saying to you, the network address, just to confirm the network address, this is what you do. If you are not certain, this is what you do. So what it means that it means that 2 networks, like it said, 2 are directly connected to this router. Here 1.1 and 2.1. Well, when I 3.1 and 3.1, it is remote to that network. So the only way you are going to learn about remote networks, the networks that are not directly connected to a specific device, we have 2 types, 2 ways to learn about remote networks. Statically and dynamically. 2 ways to learn about remote networks. Statically and dynamically. When we talk about dynamically, we talk about routing protocol. They are beyond your syllabus. It's for INT. You will see when should you manage to register or get into the diploma, we will meet again in second year to get INT, where I'm teaching about routing protocol. For your syllabus, I'm going to teach you about the static routing, so that as right now, what's happening, let's see. Let's say I want this PC, the 1.21, to communicate, to send a message to the PC1 demand, 1.3, 1.3, let's do it. For us to be able to check for connectivity, you are going to say command prompt, you are going to say ping. The command ping is used to check connectivity. Ping the name where you want to be, the person that you want to see if you can reach. It's 192.168.1.3. So when it sends replies, that means when it sends replies like this, it means that the destination host is reachable. When I show you this screenshot, then I say to you, what does this screenshot means? It means the destination host 192.168.1.3, it is reachable. Hold on again. But if we want to send a message to 3.3 while we are here, check the response. 192 dot ping 192.168. What is the IP address? 3.2 net. Here. It's a destination unreachable. That person or remote. You want to communicate with that person. Let's say I show you this, then I ask you, what does it mean? When he says destination host unreachable, what causes this error? I give you a display with error. What causes this? Let's say you are writing, and I say, what causes this? But give 6 months. What causes this error? Because it's simple. Because the destination host is remotely to the source. The source host. That means the destination host is remote to the source. And the only way to solve it, then I ask you, Ogote, what causes this and why? And how do you solve it? What causes this is because the destination host number one is unreachable because the host is remote to the source, right? It's remote to the source, that's number one. To solve the problem, you have to configure a device with static routing or dynamic routing to learn about remote networks. Like I said, we learn about remote networks in 2 ways, statically or dynamically. Does it make sense? So that means that at this point in time, your topology can only communicate locally. First network can only communicate. First network, PC 1.2, 1.2 can reach 1.3, can also reach 1.4, we can do that. But it cannot communicate with remote networks. Let's try to pin 1.2 while we are in 1.4. Pin 192.168.1.2. Thank you. 168.1.2. That means what it means is that the local area network can communicate with one another. Those PC2, PC3, I mean 1.2, 1.3, 1.4, they can communicate with one another. But the minute they need to get out of their own network and communicate with people who are outside, they cannot do that. How do we solve that? You configure a device with static routing or dynamic routing. Let's do that. So this is what you do. First, you check which network is not appearing on this device, on this router 0. Hit 3.0 again. Because one remote again. 1.0 and 2.0 they appear. That means what does not appear is 3.0. So we are going to configure the router with 3.0. Let's do that. Where do you do that? On your global configuration mode. You are going to say IP root as the command. Root. Then the network address that does not appear on the routing table. It's 192.168.3.0, right? Then the subnet mask is 255.255.255.0. Then here's the thing, the exit interface. Remember again I said the exit interface is like the Matile Zwang to that router. The Matile Zwang to reach that network. So you have to check. When you are here, what is your, in fact, let's not use the exit interface. Let's use The next hop, oh, it might need me to change the Ethernet cable. Remember the crossover in between the routers, that is an Ethernet cable. That means for us to communicate remotely, we need a serial cable. Okay, I will change it. Okay, that's fine, I will change it. Okay, but hey, let me explain this. The next hop, when we talk about a hop, we're talking about the next router. Just for that, our language is the next hop, which is the next router interface. When you are here, the next router interface, you're putting it. That means it's supposed to be 2.0, 2.2. That means when you configure a static routing, is the command IP route, then the network address of where you want to go. We want to reach 3.0, the subnet mask of that network, right? And the next hop IP address is the IP address of the next router from where you are. So that means it's supposed to be 2.2. 192.168.2.2. Then you are done. Then because you cannot communicate with someone that you don't know, if you check the routing table of router 1, let's do it, router 1.0 high number, you do not have 1.0. Level. You don't have 1.0. So you can't communicate with someone that you don't know. So we must configure 1.0 in that another for them to be able to. Then we are going to change the interface. I mean the cable. Understand me, tell me A. What is the next hop IP address that we are going to use? What is the next hop IP address? Let's say you, like now, you want to continue on the same exercise instead of us starting afresh now and then. So you save your configuration. So that means you are going to say copy, run, it stands for running, running configuration. Everyone can hashtag to start up. Configuration. Something's like how did they look like home? Okay, I think maybe the line somewhere. Let me try this way. I can't remember. In full. Okay. How do you save in full? Will be specific. Full. Or in a run means copy, run, start in short. So now what I have forgotten is that run stands for running configuration. Start stands for startup configuration. The difference between running configuration is like your RAM. It's like your random access memory. Kind of what is RAM? What type of a memory is RAM? It's a volatile memory again. A. Volatile memory, it means that if you switch off the PC without saving your information, you have to start afresh again. Yes. That's running configuration. It's like your RAM. That means whatever that you are doing, yes, it's stored temporarily so, but should you switch off the PC without saving, everything that you've been doing is going to be lost. That's why it's a running configuration. So what we are doing, your startup configuration is like your permanent memory. Kind of what is another type of permanent memory? A non-volatile memory. Yeah. ROM besides ROM. Eh? Huh? Hey. So now you are saving to startup memory so that after logging off, also classing, when you get home, you just want to continue where you left off. Everything is still going to be there. So we are saving, it's like we are moving from a volatile memory to a non-volatile memory for us to be able to continue working. So now, we're working so start up in between there must be, that means the line is supposed to be between running and start out left. So your both are destination 5, and you're going to say yes, you press enter, then you are saved. This is how you save your configuration. Let me do it again in full. I think who googled it? Who found it? Oh, who googled it? So that, because I'm going to ask you, I'm going to say, how do you save your configuration in full? So we must know it. You must know it. Google in packetry, so to be specific. Yes. So that means I was right, just that the game was a confident configuration. But I feel like running config, set up config. That's how you save in full, then you say yes. I'll run again. Yes. Alright, that's all I wanted to do with you today. So you can somehow configure those circuit routing, then I think